Thank you, Javier.
Hello, everyone. Thank you. In this opportunity, I want to share with all of you the sepsis and mortality predictive model using deep learning. I'm Javier Camacho. I'm from Colombia. So this is my work group. And let me introduce you to Segundo Camacho. He was my grandfather, a typical Colombian patient with 87 years old, with diabetes, with hypertension. And 5 years ago, my grandfather was readmitted to the emergency department because urgency, because of recent abdominal surgery. And after 4 days in hospitalization, he was sick with pneumonia. And his vital signs was really worst. Tachycardia and the systolic blood pressure was down around 65. And he was transferred to the ICU, and there he developed sepsis, and in a few days he died. So my grandfather did receive the right treatment, but the problem was receive them too late. Sepsis is common, is deadly, is really costly. But what is sepsis? Sepsis is defined as life-threatening organ dysfunction caused by dysregulated host response to infection. Actually, is incompletely understood, but several infections can lead to sepsis. The most common are pneumonia, urinary infection, abdominal infection, and skin infection. In Latin America, around 76% of infections are related with Klebsiella, E. coli, pneumonia, Pseudomonas, and in the others. So sepsis can progress to septic shock. Is a more complex step, and the systolic blood pressure drop to dangerously down levels. The patient needs vasopressors. The lactate level is really high. So another consideration in sepsis is the organic dysfunction can affect brain, heart, lungs, and livers. So in the United States, around 1.7 million patients develop sepsis, and millions patient deaths across the world. And the mortality is around 10 to 40%, and is the number one cause of death in the ICU, and the treatment of sepsis is really expensive, and more expensive in Colombia. So what is the problem? Sepsis affects patient, the oldest patient, and the newborn, and patient with in the immunology system, and affect also the delay treatment with antibiotics. So the challenge is predict sepsis early. So the mortality of sepsis is more complex, is around 80% per every hour. So the most common delay is, for example, the laboratory test results. So when the patient is diagnosed with sepsis, maybe it's too late. So the challenge is predict sepsis early. So the availability of the data, of the information, and the electronic medical devices can arise like big data, like artificial intelligence. So these kind of tools can create a good tools for predict some predict, for example, sepsis. So I am a clinical engineer, and it's natural to ask how can we create tools for predict sepsis and save life, like my grandfather. So the opportunity or the goals is to develop 3 models using deep learning and select the best. So analyze this data using information from ICU using a free database, and analyze the progressive learning and select the best model. So this is the description of our project. So we use Mimic3, is an open source de-identified database from Beth Israel Diacon's Hospital. So this kind of database has electronic medical records, laboratory test results, and biomedical signals. And the data analysis was using a CRISP DM methodology, feature selection, and cleaning, and performs 31 variables. So the tool selected was Google Colab. So it's a free cloud service in the web based on Python and using TensorFlow. So the best algorithms was deep learning, and we developed 3 models. And finally, we select the best model for predict sepsis, for predict length of stay, and for predict the mortality for this kind of patient. So this is Mimic3, the database. This is the link in the internet. So we use Postgres SQL for extract all the database. This is all of the cohort patient. So this is the extract sequence. So finally, we select this around 6,000 patients for cohort to test our model. So we use this cohort and we use the first 24 hours data, and the data was vital signs, some scores like SOFA, like Sears, Glasgow Index, the age, laboratory test results, and comorbidities. And we use Python, and we run different models, and the best model was deep learning. So we use a typical feed-forward network deep learning, and we use 2 activation functions, ReLU and sigmoid, and we develop these 3 models: basic, medium, and advanced. The difference of all is the number of hidden layer and the number of neurons. So this is the results. It's very interesting because it's possible to predict mortality. Our research, this is the basic, because the next step is collect the real world data from our patient from Colombia. And actually we are working with 2 hospitals in Colombia, and we have 2 projects, and the idea is to collect all the data from the ICU unit, data from the electronic medical records, monitors, laboratory test results, and diagnostic image. So the idea is to evaluate this kind of model and try to predict sepsis. So thank you for your time. So this is our research, and this is the future of the technology for healthcare. So thank you very much.